Hello friends, welcome again to this channel. This is G Solutions, where we find solutions for your needs. So today let us investigate the power, current, and power waveform. By the way, if you are going to get the average power, we just simply get the integration of B sub AB multiplied by the current. So we just integrate this with respect to T, and we are integrating this for over a period, so 1 over T. So it is from 0 to T. Okay? So we have a value of this one in our previous video, and also value for the current in our previous video. Now if you are going to recall on that values, we can write here 1 over T, T to 0, okay, that is actually 0.5, the maximum value of your voltage and your current, and that will be cosine multiplied to cosine theta minus cosine and twice omega plus twice P minus theta. Okay, so this is with respect to T. So if you are to integrate this one, manipulate it, you will have a simplified value of 0.5. Okay, maximum value of your voltage times the maximum value of your current multiplied by cosine theta. Okay, so this is it, but you can also have the RMS value of your voltage and current in your power. So average power by having the RMS value, since that PM and IM is changed to RMS. We know that the RMS value, for instance BRMS, is actually the maximum value divided by the square root of 2. For your IRMS, you have the maximum value of your current over square root of 2. So square root of 2 as your denominator here, and square root of 2, so that will be 1/2. And 0.5 BM and IM can be actually be represented as the RMS times IRMS cosine theta. Okay, so if you have a maximum value, you just multiply that maximum value and multiply it by 0.5 times cosine theta. But if it is an RMS value, you just multiply the voltage value in RMS and current value in RMS and multiply it by cosine theta. That will be the average power. Okay? So the function of cosine function here, theta, plays a role, and we can determine if it is an inductive or a resistive or a capacitive circuit. No? So actually we can determine if it is an inductive circuit by knowing this angle theta. And because theta here is actually the difference of the angle of the voltage and the current. Now, if you have a zero angle, that is a resistive value. Now, if your angle is is lagging, that will be an inductive circuit. And if it is leading, that is a capacitive circuit. Now, if you have a 90 degree angle, that will be a purely inductive circuit. If that angle represented in phasor form, if this is your V and your I is here, so this is a thing where you can say that the current lags the voltage. So this is pure inductive. Now, if your representation is like this one, this is your voltage and your current is going up, so your current leads the voltage by 90 degree. So this is pure capacitive. Okay? But if your voltage is here and your current is also here, so this is a pure resistive circuit. Okay? And we easily determine the theta by considering the inductive reactance and the resistance. Okay? And also the capacitive reactance and the resistance. We just take the inverse tangent of that, for we represent the reactances and the resistances and the impedances into a right triangle. Okay, and the theta there is the angle. Okay, now we have this so-called the conjugate. Okay, it is so easy for us to get the other types of power. I want you to know that there are three types of power. We have the real power, and this one is the reactive power, and also the apparent power. Okay, so the real power is the power consumed by the resistor, and the reactive power, these are the power that is made, or it happens because of the presence of inductor or a capacitor. So it can either be more capacitive or more reactive. And the apparent power is these are the power that represent the real power and reactive power in right triangle. So we represent these three powers into a right triangle. Okay, where this part is your real power, is your R, and this one is the reactive power, and the hypotenuse is the apparent power. And we have here theta. Okay, so easy for us to solve for the power here if the other power are given. If one power is given here and you have an angle here, you can solve for the other powers. Okay, so we just use trigonometric system or the Pythagorean theorem. We just use that. Okay, so we can easily solve for S, Q, and R. So you'll notice here that we can also represent this into a rectangular form. So we know that S is equals to P plus JQ, where P is the real part and this one is the imaginary part. Okay, so therefore if you can represent it into a rectangular form, you can have this also be in polar form, and that is actually okay, B. This is where we introduce the what we call the conjugate, BI conjugate. Okay, so B here has a value of B is of phi, and your I, which is italicized, as negative phi plus theta, or it is written here in conjugate form. Okay, so therefore knowing this one, if you are to multiply this one, that will be V times I. So this will be added, negative V and positive will be 0. So what remains is theta. So therefore, we can have a trigonometric representation of this one, cosine I sine. So BI cosine theta plus J VI sine theta. So therefore, your term BI cosine theta is the real part. This is your P, and this one is your Q. Okay, so it's so easy for us to get the three types of power by having the conjugate of your current. Okay, so again, the cosine and sine function of the angle theta are known as the power factor and the reactive power. Okay, so the power factor in this case, the power factor or PF is cosine theta, and the reactive factor, okay, is sine theta. Okay, so we will use this soon. Okay, so I am writing this one. This is the power factor and this is the reactive factor. So it is written here for the real power term and for the reactive power term. Okay, so this is all about the voltage, current, and power waveform. Thank you so much for watching this video.